Okay, well, hello, Honors Algebra 2. This is the third and final lesson for this week. Today we're going to be talking about trigonometric applications. In addition to your notes today, we will not need your unit circle. However, you will need a calculator that has the sine, cosine, and tangent buttons on it. So be it your graphing calculator if you've got one, a scientific calculator. Remember, if you don't have access to either of those, there is the scientific calculator on Desmos that you can use, which is actually the one I've got over on the right side of my screen right now. Okay, so let's just jump into things. Example 1, to measure the width of a river, you plant a stake on one side of the river directly across from a boulder. You then walk 100 meters to the right of the stake and measure a 79-degree angle between the stake and the boulder. What is the width W of the river? So notice the picture's already drawn there for us, which kind of makes it a little bit easier to work with. You've got your angle of 79 degrees. So based on that angle, W is your opposite side. 100 meters is your adjacent side. So opposite and adjacent tells us that we want to be using tangent in order to solve this problem. So let's set up our equation. Tangent of 79 degrees is equal to our opposite side W divided by our adjacent side, which is 100. And then to solve, just multiply each side by 100. And W is equal to 100 multiplied by the tangent of 79 degrees. And then we'll get our approximation here. So we'll type that in over on the right, 100 tangent of 79 degrees. And that is approximately 514.5. We'll just go to the nearest tenth. So 514.5 meters. Cool. All right, let's take a look at number 2. So a ladder leaning against a wall makes a 70-degree angle with the floor. If the ladder is 15 feet long, how far up the wall does the ladder reach, and how far away from the wall is the bottom of the ladder? So this time we're going to look for two things. I'm going to call the distance between the base of the ladder and the wall X, and then the height of the wall, I'll call that Y. Let's go ahead and find the height of the wall first, since that's what it asked for in the first question, was how far up the wall does the ladder reach. So in this case, you've got 70 degrees. Y would be your opposite side. 15 feet would be your hypotenuse. So opposite and hypotenuse, we would be wanting to use sine. So the sine of 70 degrees is equal to opposite over adjacent, or opposite over hypotenuse, so y over 15. And then to solve that, just multiply each side by 15, so y is equal to 15 multiplied by the sine of 70 degrees. And then for our approximation here, 15 sine of 70 is approximately 14.1 feet. And make sure you're including those labels when you're writing down your final answer. Okay, now let's go ahead and set it up for our distance from the wall X. And again, that would be your adjacent side. So now instead of using sine, we're going to want to use cosine of 70 degrees is equal to our adjacent side X divided by hypotenuse 15. So then we'll go ahead and multiply by 15 on each side. So X would be equal to 15 multiplied by cosine this time of 70 degrees. And then we can go ahead and get our decimal approximation. So 15 cosine of 70 is approximately 5.1 feet away from the wall. Cool. All right, moving on. And I think we've only got 2 more examples, pretty short section of notes. And part of the reason for that, I'll talk to you more about it when we're done with the notes. But I've got a kind of fun activity on Desmos for you to go and try out. And that way you get a little bit more practice with these application type problems. So on example 3, the Katoombo Scenic Railway in Australia is the steepest railway in the world. And if you get a chance, I would just do a quick Google search for it. It's really kind of cool to see. It almost looks like a roller coaster, the way that it's, how steep it is. But it's actually a railway, so trains actually go up and down it. The railway makes an angle of about 52 degrees with the ground. The railway extends horizontally about 458 feet. What is the height of the railway? Now notice that this time they don't provide a picture. So let's draw a picture. Let's maybe make this the bottom of the railway. We'll make this the top of the railway. And then we'll make this kind of our right triangle that we'll use to solve in just a moment. So it says it makes an angle of about 52 degrees with the ground, so you've got 52 degrees here. It also extends horizontally 458 feet. That means that 458 feet would have to be the bottom of this triangle. That's the horizontal. It's not extending vertically, that would be right here. And if it just said it extended at an incline, that would be this distance right here. So be careful with the way that you label your diagram. That's going to be the most important part. So it wants to know what is the height of the railway. A lot of times I like to use y for the height. There's nothing special about it. That's just kind of what I usually do, so we'll call that y. So let's see. Based on 52-degree angle, y is our opposite side. 458 feet is our adjacent side. So that should tell you that we're going to be using tangent to solve in this case. So the tangent of 52 degrees is equal to our opposite side divided by our adjacent side. So to solve for y, just multiply by 458 on each side. And now all that we should have left to do is type that into our calculator. So let's see, 458, oops, not sure what happened there. So 458 multiplied by the tangent of 52. Man, it does not like the way the 5 is. I'll try this again here. 52 is 586.2, and let's see, we were measuring in feet, so 586.2 feet. Awesome. Just one more example problem here. So a passenger in an airplane sees two towns directly to the left of the plane. So you've got a diagram here to kind of illustrate what that looks like. So you've got your plane, you've got your two towns. So this is, we'll just call it town A, this is town B. And then you've got these distances as labeled there, distance X, distance Y. And then it looks like we're flying at an altitude of 25,000 feet. So for part A, what is the distance D from the airplane to the first town? So we're looking for this distance right here, which really means we're focusing on, I'll draw it in a little bit bolder, we're focusing on this triangle right here for right now. So to find this distance D, we need to know both a side length and an angle. And although we don't know an angle just yet, we do know that this 25-degree angle plus whatever this angle is here has to add up to be a right angle. So that angle would have to be 90 minus 25, which is 65. So this angle up at the top would be a 65-degree angle. So then looking at what we're wanting to find in relation to that 65-degree angle, we've got 25,000 as the adjacent side. D is our hypotenuse. So adjacent and hypotenuse, we're going to want to set this up using cosine. So the cosine of our 65-degree angle is equal to our adjacent side, which was 25,000, divided by our hypotenuse, which was D. And then remember, anytime you got that variable in your denominator, you can solve by doing that quick switch. So D is equal to 25,000 divided by the cosine of 65 degrees. And so approximately, let's see what that comes up with for us. So 25,000 divided by cosine of 65 degrees is approximately 59,155 feet. We'll just go to the nearest whole foot. Okay, next thing, what is the horizontal distance x from the airplane to our first town? So now we're wanting to find this distance x, that is your opposite side of the 65-degree angle we were just using, and then we've already got the adjacent side, which was the 25,000. And let's stick with the one that's exact rather than the one that's approximated, which was D. So to set this equation up, opposite and adjacent, we're going to be taking the tangent this time of 65 degrees is equal to the opposite side, which was x, divided by our adjacent side, which was 25,000. So to solve this time, we're just going to multiply by 25,000 on each side. So 25,000 multiplied by tangent of 65 degrees. And let's see what that is approximately. Looks like it's coming out to about 53,613 feet. Okay, cool. So we've just got one more thing that it's going to ask us for. It's asking us for what is the distance y between our two towns. So I'm going to kind of erase some of this work to hopefully make it a little more clear what we're looking for here. So between our two towns, we're looking for this distance right here. So we're looking for this distance y between those two towns. So really this time we're focused not on the smaller triangle like we were before, but on this larger triangle right here that I'm kind of outlining a little bit darker for us. Which means now instead of the smaller angle, we want this larger angle, which really we're going to find kind of the same way we did for our previous triangle, which is that we know that that angle plus this 15-degree angle has to add up to be 90 degrees. So if we take 90 minus 15, that tells us that we're now working with a 75-degree angle at the top here. Okay, so now here's kind of the tough part is kind of how are we going to set this up? I guess we still have what would be an adjacent side. And we really just want this piece y, but it's going to be hard to find y just by itself. So let's instead maybe just try to find the entire distance here. Which if you think about what that entire distance is, that entire distance is x plus y. But the good news, we've already figured out what x was. So a little bit later, we'll kind of plug x back in to help us solve for y. And so if you think about what trig ratio we're going to use, x plus y is our opposite side, and 25,000 is our adjacent side, which tells us that we're going to want to use tangent once again to try to solve example C here. So tangent of this time 75 degrees is equal to our opposite side, which was x plus y, divided by our adjacent side, which is 25,000. Oops, one extra zero there. Okay, so then setting this one up, let's go ahead and multiply by 25,000 on each side. So we would have x plus y is equal to 25,000 multiplied by the tangent of 75 degrees. And so then to get y by itself, we're just going to take that 25,000 multiplied by tangent of 75 degrees and subtract x from it. Okay, so let's go ahead and type that in. Let's see what that comes up with. So 25,000 multiplied by the tangent of 75 degrees. Oops, need to go back, 75. And then let's subtract x from it. And x was our answer from our previous problem. So that would be 25,000 25,000 tangent of 75 minus that answer of 53,612. And so that ends up being 39,689 to the nearest whole foot. So a little bit under 40,000 feet. Okay, so guys, that's all I've got for you for notes today. Here's a couple of reminders for you. Because of professional development, there is no classes on Friday. So we're going to be kind of shortening our week by one day. That means that I'll kind of write these as announcements down here, that your quiz number 15 is going to be on Thursday of this week, anytime between 8 a.m. and 4 p.m. If you're wanting to do any makeup work, so if you're wanting to do makeup or retake for any quizzes or tests, then I need to know by Thursday. Or not by Thursday, I need to know by Tuesday. So I need to know by Tuesday which ones you would want to take. That way I can have all of Wednesday to get those ready for you so that you can have all day on Thursday, 8 a.m. to 4 p.m. to take those. In addition, guys, there is an activity over these applications of trig. So make sure to check out Schoology for that. It's under the activities folder. It's kind of a fun activity on Desmos. I've got the access code there for you. So you'll go to student.desmos.com, type in the access code that's on Schoology. It'll just be kind of a fun activity to get you kind of some more practice with these applications, where you actually get to take some of these measurements yourself rather than just being given them to you and having to work with them in an equation. Kind of a fun way to do things that's just a little bit different. So be sure and check that out, guys. Besides that, this wraps up Unit 9. So just one more unit left for those that are wanting to make sure they're prepared for next year, which is Unit 10, and we will start that next Tuesday. So have a good time, guys, and I will see you next time.